Good morning, students. Today we will going to end our chapter, that is electric current and circuits. Today we will study about the magnetic effect of electric current. In the last video we have learned about the heating effect of electric current. What is heating effect of electric current? Ki whenever current is passed through a conductor, it produces heat. But when we pass electric current through a conductor, it behaves like a magnet, and this it produces a magnetic field around it. This is known as magnetic effect of electric current, and this effect is discovered by Danish physicist Hans Christian Ørsted in 1820. He discovered that when an electric current flows through a conductor, it behaves like a magnet and able to deflect a compass needle. What is a compass needle? It is a needle which uh, which rotates whenever it contacts in a magnetic field. So we have to do activity 3 to demonstrate that a current carrying wire produces a magnetic field. For this, material required are cardboard, dry cell, key, iron fillings, conducting wires and compass needle. Iron fillings means जो आयरन का बिल्कुल बुरादा सा होता है लोहे का. Now take a cardboard and make a hole in its center. Pass conducting wire through the hole and hold the cardboard horizontally. Sprinkle iron fillings on the cardboard. Now pass the electric current through wire from dry cell. Tap the cardboard gently. We will observe that when the cardboard is gently tapped, the iron fillings take a circular formation around the wire due to magnetic field around the wire. Now bring a compass needle near the current carrying wire. It deflects, it shows deflection due to the presence of magnetic field. You can check it from your book. There is a diagram. Uh, Now, what do you mean by solenoid? A long winding coil of conductor. देखो, in the last activity we have seen कि एक straight current carrying conductor है, बट अगर हम उस करंट कैरिंग कंडक्टर को वायर में चेंज कर दें, कॉइल में चेंज कर दें, तो वायर में नहीं कॉइल में चेंज कर दें, उसके एक लूप बना लें, ठीक है, उसकी बहुत सारी लूप्स है, जैसे जस्ट लाइक अ स्प्रिंग, अगर हम उस वायर को कॉइल की शेप दे दें, देन इट इज़ नोन एज सोलेनॉइड, एंड दिस सोलेनॉइड बिहेव्स लाइक अ मैग्नेट as long as the current is flowing through it. The magnetic field induced by it resembles the magnetic field of bar magnet. Bar magnet, the rectangular shape magnet is known as bar magnet, and solenoid behaves like a bar magnet when we passes current through it. The strength of magnetic field of solenoid can be increased by three methods. By increasing the number of turns in the coil, suppose we have two coils. In one coil there are 10 मतलब 10 turns हैं, but in second coil there are 20 turns. But which produces strong magnetic field? The coil which has 20 turns. Second method is by increasing the current in the coil. अगर amount of current increase कर दो आप coil में, ठीक है. Third, by winding the conducting wire around a magnetic material. If we wind the coil conducting wire around a magnetic field, suppose we have to take an iron piece और उसके ऊपर हम उसको coiling कर दें, then its strength becomes double, and this is known as electromagnet. So what is electromagnet? It is a coil of insulated flexible wire wrap around wound around a magnetic substance such as iron, and it acts like a magnet as long as a current is passed through it, and the coil loses its magnetism when electric current is switched off. and its strength can be increased by increasing the number of turns of coil over a given length. But there is some advantage and disadvantage of electromagnet. Advantage is that it can be switched on and switched off. Whenever we passes the current through it, it behaves like a magnet, but when we switch off the current, then it behaves a simple coil. Disadvantage, what is the disadvantage of electromagnet? It needs a continuous supply of electric current. तब तक ये इलेक्ट्रोमैग्नेट बिहेव करेगा जब तक इसमें से करंट पास कर रहे हैं. सो अगर बीच में से सपोज लाइट चलेगी, देन इट विल नॉट बिहेव लाइक एन इलेक्ट्रोमैग्नेट. सो दिस इज द disadvantage ki that it needs a continuous supply of electric current. Now we have to study about the applications of electromagnet. Electromagnets are used in a number of electrical appliances such as electric bells, electrical toys, electromagnetic doors, telephones, etc. They are also used for shifting metal scraps in a scrap yard. Doctors also use them to take out small piece of magnetic material accidentally fallen in the eye. So these all are the applications of electromagnet. Now we have to do the working principle and construction of electric bell. Electric bell, what is the principle of electric bell? It works on the principle of magnetic effect of electric bell. So here is the diagram. You have to understand the diagram. Um, there so what is this is gong, and this is hammer. When hammer strikes on the gong, it will produce sound. And here is the electromagnetic, this is the electromagnet. Iron piece, a coil of insulated copper wire wound around it, and there is a switch, and it is connected to the battery to supply the continuous amount of current. Here is the spring, and here is the soft iron armature. So now we have to I have already discussed the principle. Now its construction. It consists of a coil of wire wound around a soft iron core, a soft iron armature, a contact screw, a gong, and a hammer. Now understand its working. When the push button is pressed, the circuit is closed and current flows through the electromagnet, which attracts the armature towards it. The armature then moves towards the gong, and it strikes it and producing sound. Simultaneously, the connection between the armature and the contact screw breaks. So there results a gap in the circuit, and the current will stop. When the current will stop, this soft iron core stops behaving like a magnet, and armature returns to its original position due to spring action. And this process repeats when the switch is pressed again. So this is the working of electro bell. So I hope you will understand. Thank you very much.